Welcome to this WiseOwl Excel VBA tutorial. In this video we'll look at how we can use stored procedures and parameters with ActiveX data objects, or ADO for short. We'll begin with a quick reminder of how to execute a stored procedure using an ADO command, and how to create and append parameters to the command object so that you can pass values to the stored procedure parameters. We'll then show you how to take a shortcut by referencing the stored procedure parameters directly without needing to explicitly create an ADO command parameter. We'll look at a couple of techniques for passing values to the input parameters and show you how you can check that at least some results were returned by the stored procedure. For the final part of the video, we'll look at how you can capture values from output parameters of a stored procedure. So let's get started. Okay, to get started there are a few things you'll need to do. First of all, get a copy of the files I've prepared for this video. You'll find a link in the video description so that you can download this folder, and when you've extracted that folder, you should find it contains 4 separate SQL script files. You'll also need to have access to an instance of SQL Server, and if you haven't already installed one of those, you can learn how by using one of our previous video tutorials on either SQL Server 2017 or SQL Server 2016. Both of these teach how to install the free developer edition of SQL Server. You will also need to download and install separately the latest version of Microsoft's OLEDB driver for SQL Server. That's the driver I'm going to use for this video. Assuming you've done that already, you can head into SQL Server Management Studio, and then from there we can choose to open up an existing file to install our sample database. So I can choose Open File, browse to the location I extracted my SQL scripts to, double click to open up file number 1, Create Movies Database 2016. We can then choose to execute that script by clicking the execute button or pressing the F5 key, and it hopefully won't take too long. It's not a particularly large database, and when it's done we should be able to check the databases folder to see that it's there. If it's not, you can right click the databases folder and choose to refresh it, and then we should see the movies database sitting in its correct place. From there I'm going to head into Excel. I've got a brand new blank workbook open here, and from here I can head to the Developer tab, open up the Visual Basic Editor. Then I can choose to insert a new module into the project, and then we can get ready to write some VBA code to connect to that SQL Server database. To ensure that we get some help when we're writing our code, let's set a reference to the Microsoft ActiveX Data Objects, or ADO library. To do that we can head to the Tools menu and then choose References, and then when the dialog box appears we can scroll down through the list to find the Microsoft ActiveX Data Objects section. I'll go with the latest version available to me, which is 6.1. I can check the box next to that and then click OK. To start with, we'll write a subroutine which returns the results of a stored procedure. So let's create a new simple private sub, get results, if I can spell results properly, from, I'll just call it SP rather than stored procedure for short. What I can do now is declare a couple of variables that I know I'm going to need. So I'm going to declare a variable called cn as an adodb.connection. I'll declare one called cmd as an adodb.command, and I'll also declare one called rs as an adodb.recordset. I can then create a new instance of the connection class, so I can say set cn equals new adodb.connection. Probably the most important property of the connection object is its connection string. So let's say cn.connectionString equals, and then this is quite a long-winded string of text, but let's build it up. We'll write it once and then copy and paste it multiple times afterwards. I'll break it up onto multiple different lines as well, just to help read it. So the first thing to do is to say which provider we're using. So this is the reference to the driver that I asked you to install separately earlier on. So I can say provider equals ms OLEDB SQL. Follow that with a semicolon, and then I can concatenate the next part of the connection string onto the next line. The next thing to do is say what server I want to reference. So I'm going to say server equals, and then in my case it's localhost /SQL 2017 training. So this is the name of the server and the instance of SQL Server that you installed and you want to have access to. I'll enter another semicolon, then close that part of the connection string, stick in another ampersand, and then concatenate that to the next part, which is the name of the database. So that's nice and simple. I can say database equals movies, that's the one we've just installed, followed by a semicolon, and then concatenate that to the next part. This part is the trusted connection. So this indicates that I'm using a Windows authenticated SQL Server instance, and I'm using my Windows credentials to log into it. So trusted connection equals yes. The final part, and this is something that Microsoft recommends doing, the final part is to make sure that we map the data types between ADO and the new OLEDB driver, is to set the data compatibility mode to 80. We'll just have a quick look back at the reference to the website for this. There's a little hint about this here, about making sure that the data types between SQL Server and ADO map correctly, set the data type compatibility to 80. There's even a quick simple way that we can just copy and paste that little parameter there. So we can copy that into our connection string. So if I paste that in and say data type compatibility equals 80, semicolon, and then close the double quotes. Just to check that I've got my connection string set up correctly, it's worthwhile trying to open and then close the connection. So I can say cn.open and then cn.close. And if I use the F8 key to step through this, making sure that basically nothing happens or nothing appears to happen when I open the connection and then close it, that's a good sign indicating that I've got the connection string configured correctly. The next thing we'll do is create the stored procedure that we want to execute using our ADO command object. To do that, let's switch back to SQL Server Management Studio, and then we can close down the script which we used to create the movies database, and then choose to open up another script file. So if we click the Open File button, and then open up file number 2, create movie procedure single parameter. This little script here creates a simple store procedure. It's not particularly complicated, although it looks like there's quite a lot of code there. The main body of it is a large select statement which picks a bunch of results from a combination of different tables in the movies database. So the from clause has lots of joins in it, joining tables together. There's a select list telling it which columns to pick from those tables, a simple order by clause to make sure our results come out in a particular way, and then there's a where clause here as well, which limits the results by applying a filter to the result set. The filter, the where clause, references the name of a parameter declared in the signature of the store procedure. So after the name of the store procedure at the top, we've got get movies single parameter. We've got a parameter name called @min_Oscars. All parameter names in SQL begin with an @ symbol. The data type of this is a tiny int, which is the equivalent of a byte in VBA terms, and it has a default value there of null. So that means the parameter is optional. We don't have to pass a value into it. That's catered for in the where clause. If we don't pass a value into that parameter, it detects that and will simply return all the results from that combination of tables. So to make sure that this store procedure is created, let's click somewhere once in the background. Unlike the VB editor, SQL Server Management Studio operates on the principle that you can select part of the text and then execute just the selected part. So to make sure you don't inadvertently select the incorrect part, just click in the background of the script and then click execute. You should get this lovely message here, commands completed successfully, and if you wanted to check that your stored procedure existed, you can head to the movies database and expand that, then expand the programmability folder, followed by the stored procedures folder, and you should see that your new stored procedure is sitting there, get movies single parameter. There's also a little prefix there, dbo dot. dbo is the name of the schema that this stored procedure has been created in. All the objects we'll create in this database will belong to the DBO schema for this particular video, so that's not something you really need to worry about at this stage. To make sure we've got a little bit of help, let's just copy the procedure name. We don't have to type that in again in our VBA code. I'll copy get movies single parameter. Then we can head back to the Visual Basic editor, and now we can start creating our command object. So let's say set cmd equals new adodb.command first of all. Then there are a couple of parameters to set up for it, or properties we should set up, I should say. So we should say cmd.activeConnection equals cn. That's the only connection we have available. We don't need to, but it's best practice to state what kind of command we're going to execute. So we can say cmd.command type equals, and you can see there's an option there for executing a stored procedure. So the second item in the list there. We can then say what command text we want to set. We can say cmd.command text, and this is where we enter the name of the stored procedure. So in a set of double quotes, we can pass in the name of the stored procedure. I'm just going to paste that as I copied it earlier, Following that, we can choose to execute the command, and if we just wanted to check that it actually works without bothering about how to return the results just for the time being, we can say cmd.execute. So having done all that, if we hit the F8 key to step through this again, we'll open the connection, configure all the properties of the command, and when we execute that, that will execute the stored procedure and return a set of results. Of course, we haven't captured them yet, but we'll get to that very shortly. Close the connection and then end the subroutine. Okay, now we've established that that part's working, we can capture the results of the execute method into the record set variable, and then work out how to write the results into a new worksheet. Let's just have a quick look at the end of the execute method. If I type in a space after execute, it shows me that it returns a reference to a record set object. So that means that I can use this method to store the results in our record set variable. So let's say set rs equals cmd.execute. What I'd then like to do is create a new subroutine which will write out the results to a worksheet. We'll use this subroutine several times in the video. So let's write a separate private sub, write results, as we call it, write results to sheet. That's what I've called it in previous videos, so let's be consistent. And then we'll declare a parameter here as well, which will allow it to accept a reference to a record set object. So I'll call this one results set and say that that's as an adodb.record set. We can then declare a couple of variables within the procedure. Let's say something like dim ws as a worksheet, and then dim I as integer. I'll set ws to be equal to a new worksheet, so I'll say this workbook.worksheets.add. And then, although the worksheet will be selected automatically when it's added, you may remember the little bug from previous videos in this little mini-series, whereby if you don't explicitly select the worksheet, the copy from record set method doesn't quite work in exactly the way it should. So I'm going to say ws.select to make sure I've explicitly selected it. Then I'll use a for next loop to loop through the collection of fields in the result set. So I'm going to do it this time with a for next loop for I equals 0 to result set.fields.count -1. So the results set fields collection is indexed from 0, unlike most Excel VBA collections, which tend to be indexed from 1. I can then say next I, and then inside the loop, what I can do is say ws.cells, then refer to row number 1 and column number I plus 1 dot value equals results set dot fields, open some parentheses, I dot name. Having done that, I can simply copy the results of the record set out into range A2 on the worksheet, so ws.range A2.copy from record set, and then pass in a reference to my result set parameter. Finally, I would like to just change the column widths by saying ws.range A1.current region that was meant to be, dot entire column, dot autofit. Finally, I can just call this write results to sheet method in my original subroutine, so I can scroll back down and I can say write results to sheet and pass in a reference to my rs variable. Once I'm finished with that, I can say rs.close, and then having done all that, I can give the whole thing a quick test just to make sure that we're getting a set of results from our store procedure. So I can click the run button, and if I quickly click back into Excel, there's my list of films from my movies database. Now let's look at how we can pass a value to the parameter of this store procedure. If you watched the previous video, you may remember that we did this by creating a new parameter object, and then we appended that parameter to the list of parameters of the command. So we could take that same approach for this example, although it's not actually necessary. Let's have a quick look at a reminder of how this works. Let's declare a new parameter variable dim pm as adodb.parameter. And then after we've set the command text of the command object, we can say set pm equals cmd.createParameter. If I then open up some parentheses, there are quite a lot of parameters of the createParameter method to set, but they're all optional, and most of these we don't need to bother with actually. The name is irrelevant. The way this works, if I create my own parameters, is they'll be passed to the store procedure in the order that the parameters are listed in the store procedure's definition. So for this example, because there's only one parameter anyway, all I need to do is set its type and its value. So let's skip to the type parameter of the createParameter method, type : equals. The data type of this parameter in the store procedure is called a tiny int, and the equivalent type in ADO terms is called an AD unsigned tiny int. Then the direction of the parameter is an input parameter by default, which is exactly what we want. The size is irrelevant for this particular data type, it's got a fixed size. So let's just set the value. Let's set the value to be something like value colon equals number 8. So let's go for a minimum Oscar wins of 8. That should return quite a small number of results. Having done that, what we can do is append this parameter to the parameters collection of the command object. So we say cmd.parameters.append and then pass in a reference to our parameter object. Having done that, if I were to run the subroutine at this point and have a look at the results, I ought to end up with a list of films with a minimum Oscar wins of 8, and that's exactly what I've got. Now, although this technique works, you can imagine it might get a little bit annoying if your store procedure had lots and lots of parameters. You'd have to both create and then append a parameter for everyone in the store procedure's definition. The great news is it's not actually necessary to do this at all with a store procedure. The list of parameters is already defined in the procedure's definition. All we need to do is reference the one that exists. So let's get rid of the parameter variable, and let's get rid of the lines which both create and append the parameter. After setting the command text, you can optionally say that you want to refresh the parameters list. You can say cmd.parameters.refresh. Now, this is probably good practice, although it isn't strictly speaking necessary, because if we reference a named parameter in the command object in the store procedure, it will perform the refresh method for us automatically. All we technically need to do is say cmd.parameters, and then in some parentheses and double quotes we need to reference the parameter name as it's defined in the store procedure. If we switch back to SQL Server Management Studio and then just copy and paste the parameter name @min_Oscars, paste that in, close the double quotes and then close the parentheses, then set the value of that parameter to be equal to, let's go with a different number this time, let's go with 10 so we get a different set of results. Having done that, if I simply run the subroutine again, I'll end up with another new worksheet, and in the set of results, this time I end up with films with Oscar wins with a minimum of 10 Oscars. Just on the subject of named parameters, it might be worthwhile mentioning that although we have passed in the name of the @min_Oscars parameter here, rather than referencing the parameter using its index number, the documentation says that we should have set a different property in order to make this work properly. So there's a named parameters property of the command object, and the documentation says that if this is false, which is the default, the parameter names are ignored and the provider uses the order of the parameters to match values. Now, with a simple store procedure with only a single parameter, that doesn't really matter at all, as in our example here. Now, I have tested this with store procedures with more complex parameter lists, and it doesn't actually seem to matter. I don't think this actually is true, at least not according to the examples I've tried. But just in case it does affect you and you wanted to make sure that your named parameters are valid, you might not be using SQL Server, for example, and maybe there's a different rules for different providers. If you wanted to, you could also set the cmd.namedParameters property to be equal to true. As I say, in my case for these examples, it won't actually matter, but just bear that in mind for the future. Okay, let's move on and look at a more complex example involving multiple parameters. If we switch back to SQL Server Management Studio, let's close down script file number 2 and replace that by opening up script file number 3, create movie procedure multi-parameters. The main body of this procedure is exactly the same as the previous one. The main difference is that we have multiple parameters declared at the top of the procedure, and those are all referenced in the where clause, so we have more options for filtering the result set this time. All the parameters are optional, they all have a default value of null, and the where clause handles that so that if we don't pass a value into a parameter, it's treated as not filtering that particular column. So what we can do is execute this script to create the procedure, and if we wanted to check that that was the case, we could right-click Store Procedures and choose Refresh. Let's just copy the procedure name while we're here, so we don't have to write that in again. And then if we switch back to the Visual Basic Editor, we can then change the name of the command text. So let's highlight the Get Movies single parameter store procedure name and replace that with Get Movies multi-parameters. Now I'm just going to demonstrate this feature whereby I comment out the named parameters option here, and I'm going to stick with the min Oscars parameter. I'm going to set its value to 10. And then if I switch back to the SQL Server Management Studio application, you can see that min Oscars is the 5th of 5 parameters for this particular example. So if I were using, if the named parameters were being ignored according to the documentation, this would be passed into the first parameter, which is title. But if I execute this code and look at the results in Excel, I'll find that it's passed the value 10 again into the Oscar wins filter. So it's passing the values correctly, even though we're not using the named parameters property set to true. Just for reassurance, you may prefer to keep this in here anyway, but it doesn't seem to make any difference to me, so I don't need to technically use this for this particular example. Now let's look at a slightly better way to pass values into the parameters of this procedure. Rather than writing the values into the code itself and having to edit it in the VB editor, let's create a simple query sheet that the user can type values into. I've done a little bit of tidying up by deleting all the extra worksheets, so I'm left with just sheet 1. And in here I'm going to type in some simple headers for my basic little query system. So let's start with a quick little query inputs title. And then below that I'm going to write in roughly the names of the parameters. So I'm going to go for title text. Then I've got start date, and I've got end date. I've also got min length, and then also min Oscars. So that reflects roughly the order that I've listed them in the store procedure itself. Having done that, we can maybe do a quick bit of basic formatting. If I switch back to the Home tab, do a bit of merge and center, and then do some basic coloring in just to satisfy my need to make things look at least not simple black and white. Let's change some basic background colors there. Then I'm going to type in some basic values that I can pass into my store procedure as well. So for the title text, I'm going to type in the word star followed by a percentage symbol. The percentage symbol is the wildcard character in TSQL, so that will find films which begin with the word star followed by any number of any characters. For the start date, let's go with the first of the first 2000. And then for the end date, let's just put in today's date. The quickest way to do that is to press Ctrl and semicolon on your keyboard. From there I can enter the minimum length. Let's go for 100, and then let's say I want at least one Oscar win as well. Let's just rename the worksheet as well. Let's call this one something like query sheet. And then I'll also, back in the Visual Basic Editor, I'll also give this worksheet a code name. So if I select sheet 1 and then in the properties window, change the name property at the top there so that that's called query sheet. Remember, code names can't contain spaces, so query sheet with no space. Just to demonstrate how this will work with a simple single parameter again, let's just alter the number 10 there so that we can reference query sheet dot range, and then let's just remind myself which cell that was in. It was in cell B6 on that worksheet. So range B6 dot value. What I can then do is attach this subroutine to a button on the worksheet, but in order to do that I'll need to stop this being a private subroutine. It will need to become a public one. So I can do that by either removing the word private or explicitly typing the word public in front of the subroutine name. Then I can switch back to Excel and maybe head to the Developer tab. Have a look in the Insert tool to find the Form Controls section. I can draw a basic form control button, so I can click on the button tool. Then if I want to draw a button so it lines up exactly with the edges of cells, I can draw it while holding down the Alt key on the keyboard. If I hold down Alt and then click and drag with the mouse, it will snap to exactly the borders of cells. When I release the mouse button, I can select my Get Results from SP subroutine and click OK. Then while I'm here, let's change the text on the button to say something like Get Results. And then, having done all that, with all these values passed in, remember that I'm only going to return values with the min Oscars here, so none of these other values will be taken into account just yet. But if I click Get Results, I ought to end up with all the films with a minimum Oscar wins of 1, so there should be no non-Oscar winners in this list. At this point, all we need to do now is plug in the rest of the cell values into the various parameters. So let's switch back to the Visual Basic Editor, and then let's scroll back down again to where we were assigning values to the parameters. It might make sense just to quickly copy and paste this line and then paste it in a few times above. So let's go for 1, 2, 3, 4 more times. We can then just update the cell references to be 2, 3, 4, 5. and 6, of course. And then just update the parameter names so we can see the parameter names in the definition of the procedure at title, at start date, at end date, min length. At min length, I should say. So at title is the first one, at start date, at end date, and then finally the last one to change, at min length. Okay, so simply having done that, isn't that preferable to having to create and append a parameter for every single one in the list? If we switch back to Excel at that point, with these values filled in, if I click Get Results Now, they will all be taken into account, and I'll find that I end up with just one single film, Star Trek, the J.J. Abrams one, released in 2009. So let's just quickly tweak this to see if we get some other results. Let's change the min Oscars to 0 and choose Get Results again. Then we get a few more results this time, so we're seeing the Oscar losers this time as well. One thing to be careful of when allowing users to pass values into a store procedure is ensuring that they pass valid values. So for example, while a user can leave all these cells empty if they want to, our store procedure handles that, of course. If I click Get Results, it will return simply all of the films because the store procedure is set up to do that. But if somebody types in something invalid entirely, like in the minimum Oscars, for example, they typed in a bit of text. If I click the Get Results button this time, that will fail because I'm passing in data of the wrong type for that parameter. If I click Debug, it's no great surprise that it fails on this particular line. If I just stop the subroutine at that point, what we should really do is add some validation to the worksheet so that the user can only enter values of the appropriate type. So one way to do this, we could write some VBA code to do this. In fact, we could write some if statements in the subroutine, which will check if the type of the min Oscars cell is numeric, and if not, exit the subroutine with an error message, etc. But it's slightly easier to do this sort of thing by using Excel's built-in data validation feature. So for the min Oscars cell B6, if I head to the Data tab in the ribbon, I can head to the Data Validation tool, and then I can say that rather than allowing any value to be typed into this cell, I can restrict it to only accepting whole numbers. I wouldn't want to enter negative numbers, so I can set the minimum value to be 0, and the maximum Oscar wins of any film in the database is 11, so I just happen to know that, so I can set that to be limited to 11. And I can even set up custom error messages if the user gets it wrong. If I head to the Error Alert tab, I can provide a basic error title. This is basically like a simple way to customize a message box in VBA. So I can say Oscar wins error, and then the error message can be enter a whole number between 0 and 11. And then if I click OK, if I type in some invalid data this time and hit enter, I'm immediately prompted to fill in a valid value instead. So I can either cancel what I've done or retry. I'm forced to type in a new value. If I type in a negative number and hit enter, that also fails. So until I follow the instructions I've been prompted to follow, if I type in a whole number of 5, then I can click Get Results and return a sensible set of information according to the parameters I've filled in. Now, it's still possible, even with some validation, that the user can type in values that don't return any results. For example, if we validated the title text cell to only accept text, there's no real restriction on what the user can type in. So for example, if I look for Avengers Endgame, for example, which isn't in the database, I won't return any results at all. If I just get rid of the min Oscars result there as well, let's clear the content of that cell. If I try to click Get Results Now, I will not return an error, but I don't have any results to return, so I just end up with an empty worksheet, which looks a bit rubbish. So let's handle that. If I switch back to the Visual Basic Editor, what we can do is, before we try to write results to the worksheet, we can check whether the record set has any results in it. A simple way to do that is to check for the existence of two different markers. When record set is loaded, the records themselves are sitting between a beginning of file and an end of file marker. Now, if there are no records, the beginning of file marker and the end of file marker are essentially the same thing. So if you imagined a cursor, a pointer, pointing at a single row in the record set, if there were no records in the record set, the pointer would be pointing at both the end and the beginning of the file. So we can use that in an if statement. We can say if rs.bof and rs.eof then. let's just have a couple of blank lines then and say end if. Then we can say something like message box. Then we could say no results were returned. And then we could maybe add in a quick symbol there. We could add a VB critical symbol there. So VB critical. And then we can say simply exit sub before we get to the point where we write the results to sheet. It's possibly also worthwhile closing down the connection, although that will happen automatically when we end the subroutine anyway. You could also say cn.close and then do any other tidying up in there as well. So we could say rs.close before that as well. And again, that will happen automatically when the connection is closed, so that you don't necessarily need to do these things, but you can do if you want to. So having done that, let's switch back to Excel and back to my query sheet. If I click get results this time, I end up with no results were returned, but I don't inadvertently insert a new blank worksheet. Okay, so we've seen how to pass values into parameters in a few different examples. Let's have a look at how we can also extract values using parameters. If we switch back to SQL Server Management Studio and then close down script file number 3, and then choose to open up script file number 4, so create movie procedure output parameters. Now again, this is essentially the same procedure, or at least the basics of it is the same as the previous examples. It's just that this time we have 4 extra parameters. These are all listed as output parameters. So rather than giving information into these parameters, this store procedure can pass values back out. The code to set the values of those output parameters is a little further down. So beyond the select statement, which returns the result set, we've also got a few statements which set the values of our output parameters. There's a single line statement here that returns the row count variable, so it returns the number of results returned by the previous statement. Then there's another select statement which provides some aggregate, so a sum and a couple of averages for some values in the various columns. Let's execute this script to create the new procedure. And then having done that, we can just refresh the stored procedures folder to make sure that's appeared. And then let's head back to our the Visual Basic Editor, having copied the get movies output parameters procedure name. If we switch back to the Visual Basic Editor and then paste in our new procedure name back where it says command text, so we can pass that in now. Then let's look at what modifications we need to make to get some information out of a stored procedure. To keep things simple to begin with, let's just get the results from one of the output parameters. We'll go with the @numResults parameter. So what we can do to make this work is declare a new variable in our VBA subroutine. Let's declare something like dim numResults as long. I'll just change the capitalization there so it looks a little more consistent with other things I've done. Then what we can do is simply refer to the @numResults parameter, but where we do that we have to be slightly careful of. Of course, you would imagine that you have to execute the command first in order for any output parameter to be passed, and that's absolutely true. But what you might not realise, and I certainly didn't when I first attempted to do this, was that until the record set has been processed or closed, the output parameters aren't actually available. So we have to make sure that we've finished with the record set first before we can access the output parameters, which was one of those gotcha things. It took me absolutely ages to work out what on earth was going on there. But anyway, we figured it out. So now I can tell you gladly that, that you need to make sure you do this after you've closed the record set. So we can just refer to the new variable we've created, numResults, and we can make that equal to, and then we just need to reference the parameter in the same way we have previously. So we can just copy and paste a bit of that code and then simply replace the variable name there with numResults. And then we could maybe display that on a message box. Why not? Let's say message box, and then say number of rows returned, or number of results returned, something like that, equals, and then simply concatenate the value of the numResults variable. Maybe we'll have a VB information symbol on there as well. So having done all that, if I switch back to the Excel worksheet, and then let's actually type in something that will return some results this time. Let's go with, oh gosh, I don't know, let's go with Harry, followed by a percentage symbol. And then let's say a minimum length of 100 again, for example. So if we say get results again, we will end up with a bunch of Harry Potter films, and we will see that we get 8 results returned, and our message box tells us that because we've captured the results from the output parameter. So all that we need to do now is create variables to capture each of the other output parameters. Let's have a quick look at what other parameters we've got to capture. We've got a total Oscars, which is an int, a whole number. We've got average runtime, which is a float, and average box office, which is also a float. Float isn't a data type which exists in VBA, of course, but if you're not sure what the data type, what the equivalent data type of float is, you can map parameter data types in different languages. There are several resources for this, but a nice simple one to use is the W3 Schools ADO data types list. This is a handy reference to have. So if you have a look down the list for SQL Server, first of all, you can find the float type, and then you can see that in things like in ADO, that's referred to as an AD double, and it lists access, but access and Excel use the same VBA language, so the type for access is a double, so that means we need to declare variables as double to capture the result of our float. If I switch back to the Visual Basic Editor, we can declare a couple of extra variable names in this subroutine. So let's go for dim total Oscars as long. So the equivalent of int would be long in VBA. Then we can say dim AVG length as double. And then finally dim AVG box office also as double. We can then scroll down to the bottom of the subroutine, down to where we were capturing the value of the output parameters, and let's just copy paste that line a few times to make life slightly easier. We have 4 copies of it. So we have num results. Let's change this now so that it's total Oscars, and then we can make this equal to the @total_Oscars variable. So I'm just going to copy that from SQL Server Management Studio. Then the next one will be AVG length. And again, I'll switch back to the SQL Server Management Studio to copy and paste the AVG runtime parameter name. I just want to avoid using the wrong names here. And then finally, I've got AVG box office. And once again, I can go back to SQL Server Management Studio, copy the parameter name, and then paste that in to the appropriate part of that line. Now that I've captured the values, I can try to display them in my message box. So let's just alter the code that displays the message box. Let's break this up across a number of different lines, as it's going to get quite long. So I've got number of results returned equals and num results. At that point, I'd like to concatenate a new line character. So I can say VB new line, followed by another ampersand, and then a space underscore. And then I can say total Oscars equals, and then concatenate that with the value of the total Oscars variable. So total Oscars, and then concatenate that with another VB new line, and then concatenate that with average length or average runtime. It doesn't really matter how I show this. Average runtime equals, and then concatenate that with the AVG length variable, and then another VB new line. I'll spell that properly, VB new line, and then concatenate that with one final new line character, and we can say average box office equals, concatenate that with the AVG box office variable. Then I've got my simple VB information symbol there. I could also add a simple title to the message box as well. So let's add in a title to the message box which says query results. Why not? Okay, so having done all that, if we were to head back to the Excel worksheet at this point, let's just tidy up the other worksheets by right-clicking and deleting them, and then head back to the query sheet. Should we try something different this time, or should we stick with the same one? Let's try something different. Let's go with king this time. Maybe I'll add a percentage symbol at the beginning of the phrase as well, so we'll see the word king found in all sorts of different places. I'll leave the start date and end date as they are. The minimum length can stay as it is, and then if I click get results this time, There we go, so a nice set of different results this time. Unfortunately, including some Twilight films, disappointingly, but sorry, we have to. I should have deleted those from the database. Never mind. We'll leave those as they are for now. So there we go, some interesting techniques there, passing values into parameters of stored procedures, and also getting values out of stored procedure parameters as well, using output parameters. So I appreciate that's a little bit sort of specialised compared to some other techniques we've used in this video series in the past, but handy to know how to do that if you ever find yourself in that situation. So hope you found that one useful. Thanks for watching. See you next time.